You're doing 100 kilometers an hour, sun overhead, open road. Then the highway just drops. No warning sign prepares you for what happens next. The road plunges straight down into the seabed, and suddenly there are millions of tons of ocean sitting directly above your roof. You haven't crashed. You haven't hit a glitch in the simulation. You're driving through one of the most audacious pieces of engineering humans have ever built. This is the Shenzhen-Zhongshan Link. 24 kilometers of bridges, artificial islands, and a tunnel buried under the seafloor, built in 7 years for $6.4 billion. Before this thing existed, getting from Shenzhen to Zhongshan, two cities separated by a bay you could practically swim across, meant a 2-hour crawl through gridlocked traffic on a bridge built decades ago. Now it's 30 minutes. Not because the distance changed, because engineers refuse to accept the old rules of what a bridge could be. Stick around, because this project just broke 10 world records, and by the end of this video, you'll understand exactly why engineers on the other side of the planet are struggling to explain how it was even possible. Subscribe if mega engineering is your thing. Let's get into it. Here's the problem nobody could solve for 30 years. The Pearl River Delta is one of the most valuable stretches of land on Earth. 11 cities, 86 million people, a combined economy bigger than Spain's. But it's cut in half by water. Shenzhen and Hong Kong's tech money on one side, Zhongshan and Zhuhai's factories on the other. Build a bridge, connect the two halves, multiply the economy. Simple, right? Except the estuary was booby-trapped by its own geography. Trap 1. The sky. Shenzhen's international airport sits right on the shoreline, and its flight paths cut low across the water. Build a suspension bridge with towers tall enough to clear shipping lanes, and you've just built a 200-meter obstacle course for landing aircraft. Trap 2. The sea. Beneath those flight paths runs the Lingding Channel, one of the busiest cargo corridors on the planet, feeding the ports of Guangzhou and Shenzhen. Ships that size don't slow down for anybody. Build your bridge too low, and you've just strangled one of the world's busiest trade arteries.
I agree, that will optimize the airflow.
So planes owned the sky, ships owned the surface, which left engineers exactly one option nobody wants to hear. Go underneath everything. Sink the highway below the ships and only bring it back into the air once you're clear of the flight paths. On paper, it sounds simple. In practice, it required inventing new engineering just to make it possible. To go from bridge to tunnel, you need solid ground in the middle of open ocean. There isn't any, so they built some. Normally, building an artificial island means dumping millions of tons of sand and rock into the water and waiting, sometimes years, for it to settle and compact. Engineers didn't have years. The shipping lanes couldn't be shut down, and the clock on this 7-year project was already ticking. So they skipped the waiting entirely. 57 steel cylinders were built on land, each one 28 meters wide, over 40 meters tall, weighing around 650 tons. Think of them as giant steel drinking cups, big enough to swallow a 10-story building. Crane vessels floated them out to the site and vibrated them straight down into the seabed, side by side, until they formed a solid steel ring in the middle of the ocean. Basically, a stadium-sized cup with the ocean poured out of it. Pump the seawater out from the inside, backfill with sand, and you've got land. Real, stable, buildable land. Assembled in months instead of years, in a spot where a normal dredging operation would have taken far longer and shut down shipping the entire time. One of the two islands became a simple transition ramp. The other did something nobody had attempted before. It became the world's first underwater expressway interchange, letting
Merge
drivers
left onto the
exit
main
directly
highway.
into Shenzhen's airport traffic loop while still technically below sea level. You could take an exit ramp underneath the ocean. Let that sit for a second. Now the part that should terrify any engineer, sinking the actual tunnel. This isn't a bored tunnel drilled through rock. The bottom of the Pearl River estuary is soft silt, the engineering equivalent of building on wet sand. So they used a method called immersed tube construction. Build the tunnel in giant prefabricated chunks on land, float each one out to sea, and sink it into a trench cut into the seabed. The scale is almost cartoonish. The tunnel stretches 6.8 kilometers, built from 32 individual segments plus one final closing piece. Each standard segment is 165 meters long, 46 meters wide, 10 meters tall, and each one weighs 80,000 tons. For comparison, that's the weight of a fully loaded Nimitz-class aircraft carrier. Except instead of floating on the surface like a ship, this thing has to sink, land in exactly the right spot on the ocean floor, and lock into the segment before it with millimeter precision. Getting there required its own factory, a fully automated facility that poured self-compacting concrete into double-walled steel shells with zero tolerance for error. A single trapped air bubble under the crushing weight of the ocean above could crack the entire structure open. Each pour used 29,000 cubic meters of concrete in one continuous shot, a world record on its own. Once cured, these 80,000-ton blocks were towed 50 kilometers out to the installation site on a custom-built double-hulled vessel. Then came the hard part, sinking each segment 100 feet down through shifting currents and aligning it against the last one, using China's Beidou satellite navigation system to hit a tolerance of less than 2 millimeters. 2 millimeters on an 80,000-ton object. Underwater, 32 times in a row without a single failure. The tunnel is now patrolled by 14 autonomous robots that check the cables, monitor for problems, and can even respond to accidents in real time using onboard cameras and speakers. It's less a tunnel and more a living structure that watches itself. On the far side of the crossing, once the flight paths clear, the highway climbs back out of the water and onto the Lingyang Bridge. And this is where the records start stacking up fast. Main span, 1,666 meters, the longest span of any fully offshore steel box girder suspension bridge on the planet. Towers, 270 meters tall, roughly a 90-story building rising straight out of the ocean. Deck height, 91 meters above the water, the highest of any sea bridge in existence, giving container ships 76.5 meters of clearance to pass underneath without even slowing down. Here's the part that should really stick with you. This sits in one of the most typhoon-battered regions on Earth. So before construction even started, engineers put the bridge deck through wind tunnel torture tests, simulating gusts of 83.7 meters per second. That's over 187 miles per hour, stronger than a Category 5 hurricane. And the bridge passed. Even the road surface is a record holder. Standard asphalt cracks when steel expands and contracts with the seasons. So engineers used a specialized hot mix epoxy asphalt across 378,000 square meters of deck, the largest application of its kind ever recorded. It flexes with the bridge instead of fighting it. The anchors holding the suspension cables in place used 344,000 cubic meters of concrete, the largest offshore suspension bridge anchors ever poured. This bridge isn't just tall. It's built to take a direct hit from nature's worst and keep standing. Strip away the record-breaking numbers for a second, because the real story here is economic. This link physically fuses two halves of the Greater Bay Area, a region of 86 million people generating over $2 trillion in GDP, roughly the size of Spain's entire economy. A tech company in Shenzhen can now reach a factory in Zhongshan in under 30 minutes. Supply chains that used to take a full workday to coordinate now happen in the time it takes to finish your coffee. 7 years, groundbreaking to opening day, 10 world records, 2 artificial islands built without waiting for nature to cooperate, 32 aircraft carrier weight tunnel segments sunk with millimeter precision, a bridge engineered to shrug off a Category 5 hurricane. If this kind of engineering breakdown is your thing, subscribe. We do this every week, and I want to know, which record impressed you more? Sinking an 80,000-ton tunnel segment underwater with 2 millimeter accuracy? Or a bridge deck sitting 91 meters above the waves? Drop it in the comments. I read every one of them. See you in the next breakdown.